Hi there and welcome back to Triplicate, and after some months we're going to have another look at our decorative mood light, and we're looking to upgrade this which I plug it in. There's a few feeble little red and white LEDs in it. So we can, I'm sure, do much better than that. And to that end, we bought some Neopixel LED strip. We connected it up to the Arduino and we wrote some basic code. So we got that far, which was just basically for test purposes, but then this happened. So I had this just hung up on end in the office, get it working, got this sort of rainbow effect. Just to try it out, and Angela said, hey, if that was in a semicircle it would be a really good NHS Solidarity rainbow. So here it is in our front window, and I guess this is going to be its job for the duration, so perhaps the mood light project is going to be put on hold a bit. So now we want to move on with this. Plug it, blinding me, so it's probably blinding you. They're so bright, these things. Now, well, firstly, should we disconnect this thing, grab this thing and see what's in here. So it should just lift off. No, it doesn't. It does. Come on. That's a good fit. So in here, you can see that we have the battery boxes for the old LEDs, and the LEDs were just wrapped in a bunch of bubble wrap very effectively. So there we go, and they were just connected across actually 5 volts. So that's what we've got, and we don't have anywhere near 60 LEDs in there. So you're not going to need all 60 of these in here. Plus, rather annoyingly, you see these are actually a straight strip, those, which I've had to sort of manoeuvre about a bit to get in the semicircle. And you can get straight strips, various lengths, you can get circles, and you can get arrays, but nobody will actually sell you, that I've found, I mean, look at that, just a load of these separate you can wire together. So first thing I think I am going to do is see if we can actually separate these and see if I can rewire them up with some little lengths of wire between them. Okay, so most of them seem to be fastened together with these little sort of gold link things. I don't know what they are. Oh, we'll find out, but halfway along there are actually 3 soldered ones. And if we go right to the end, there are 3 that are soldered, so presumably we can extend it if we want to. So for now there is some double-sided tape on the back so you can stick it down. So for now we're going to take a knife and we're going to get rid of that for start-offs. Alright. So there are those, are there? We're going to put a pair of scissors through that. Get rid of that. I'm going to try and pick this double-sided tape off. Alright, so that tape doesn't want to come off too easily. So for now, we're just going to leave it, unless we absolutely have to take it off. So what I now propose to do is use the tape to our advantage. I propose to zoom you in. There we go. And I'm just going to take the knife and cut across this junction. Flexible PCB, which is tougher than I thought. Alright, still in shot. Let's try a stout pair of scissors, as they say. Okay, so now shall we see if we can actually solder to that gold coloured stuff. Okay, get rid of that soldering iron, solder, tune shot a bit better, let's go, let's try it. Looks good actually. Well, that was easy. Should now get 3 small pieces of wire and solder them across there, and then we'll fire it back up and see if it's still going. Okay, 3 bits of wire. Let's move that somewhere else. Plus signal ground again. Plus signal and something called my ground. There we go. Looks alright to me. Right, I'm just going to get the meter and check none of those are short circuit. Not that I have no faith in me in soldering. Yeah. Yep, they're not short circuited and they're connected up correctly, so should we... Oh, let me zoom you out a bit. Oh, wrong way. Always the wrong way. Reconnect the Arduino and see what happens. Oh look! Well, that was easy. Okay, so I've just taken what I got and wrapped it sort of in that bunch of bubble wrap that the original LEDs were in, and stuffed it in to try and get an idea of, for a start off, how many we want. And would we say that's about right? If we can turn it and have a look at... I would say that's about right, and I would say that's probably actually somewhat over half, but some of them are scrunched up in the middle there. Sorry, the hand cam. So I think I am going to go for half, so that gives me a complete spare set in case I destroy them or something. So next we want to try and find out how we're going to suspend them in there, hopefully so the light from them is sort of diffused out, so that they don't just look like a bunch of LEDs stuffed in there. So I'm going to have a think about that next. Okay, so we also have an additional constraint, I suppose. We've got to consider that whatever we put in here has to go through this hole, which is considerably smaller than the diameter of the bowl, glass thingy. So there's no point just trying to build something that fits inside, because we couldn't get it inside. Okay, so this is what I'm proposing to do. Take some clear plastic. This is Christmas wrapping. And cut a strip of it without the Christmas tree on. I could use the Christmas tree. And on that strip, this was my first attempt, and I tried soldering it after I stuck it on, and stick a piece of this aluminium cooking foil there in the middle. Get the LED, so, and glue that end there, and they fortunately have tape on the bottom. Run it round and glue the other end on the bottom, and we now have a reflector opposite the LED. So because these LEDs are very bright, we now get the reflected light, not the direct light from the LED. Plus the fact this forms a volume, so assuming these are the right size, big assumption, then as we feed them in to the bowl, they should fill it up. And my very rough calculation tells me that that is about the right size. So here is one that's made, not very accurately because the reflector isn't in the right place. So should we power it up and see what it does? So there we go. And as it comes round, you see, you don't see the direct light from the LED, and as it goes round, you see the reflections from that piece of foil. So I am going to make 30 of those and 30 little wire links, probably a tad shorter than that. And unfortunately this stuff I do not think is going to be stiff enough, so I'm going to have to order some stiffer thin clear plastic. So this is as far as we can go on this part of the job for the moment. Okay, so the idea was to make this thing respond to its environment. So to that end we have a motion detector module, we have a light sensor module, and we have a little microphone and preamplifier module. So shall we just connect these up and have a look and see what they do and whether they'll actually be useful and do what we want them to do? So what should we start with? Left to right. We'll try the PIR first. Okay, so here are the pinouts. So let's put this on here. I've just got a bit of a headache on those pins, supposedly, and there we go. So this side is 5 volts. This side is 0 volts. Come on. And here we have an LED. So this is, I'm trying to see which, yeah, this side that's sticking out is 0 volts. According to the data sheet, it will put out just about enough current to light an LED. So Robinson. I should have soldered it, I suppose. Okay, so I decided to come up with a slightly more robust setup for it. So it's just the usual bit of Veriboard, the LED there, and we plug it in. I also decided to have a play around with it off camera, and it did seem to be doing what we wanted for a while, and then I fired it up one time while I was fiddling with the settings on the pots here, and now I'm hoping the camera's going to pick me up. Yeah, it's just on all the time. However, we have another one. So let us turn that off, and I am going to plug this in with whatever it's set up to out of the bag, and shall we see what this one does? Right, she's in. There we go, that's more like it. Apparently it takes a little while to set itself up and settle itself down. Yep. So you can't see I'm moving about out of shot. Sort of should see me now. The sensitivity is the one near this, which sets the re-trigger mode. So should we, well, I'm assuming we turn the preset up for more sensitivity. Yep. And the other one sets the off time. So I'm just continuously moving backwards and forwards here. So if we set the off time down, yes, no, come on, or up, it comes on continuously. All I did was fiddle with a little pot, set it at half, set the sensitivity to minimum, and suddenly on all the time again. We set this back to I mean, is it on all the time because it's detecting all the time? But what's the point in that preset if it only actually does anything when it's set to minimum? Set that back to minimum. Spin it round that way, and I will try and stay completely still. Okay, so we go back to the other one and we set that up. We go on the same. That one about there, and this one down to the minimum. Yep. It's actually working, I think. Come on, there you go. It's just this off time preset doesn't seem to be doing anything on either of them, so do we think it's some kind of a design fault? Oh well, they work, if not exactly as how they claim to. So shall we move on and have a look at this, a little light sensor. Okay, so here we have our little temperature sensor board, again mounted on the bit of error board, and that's the output of it to the plus of the meter, negative of the meter going to ground, and powering it at 5 volts. You see with all the lights and everything on, it's around 2 volts. So should we just turn the room lights out? Goes down to 1 volt. That's just a daylight, but it's a dark grey day here in York. So if I hand over it down to 40 millivolts. So I think that works alright. That's pretty easy, straight into a A to D input, and we're good at that. Okay, so we've wired up onto our little test board microphone amplifier and microphone module. Now according to the data sheet, and in fact what it says, on the other side of the board the output DC offset should be 1.25 volts. So I think that's the first thing to check. We'll bring the supply up and see if that is what we get. And we'll turn the meter on and turn the supply on down at 0 volts. Let's bring the voltage up. Oh, there we go. Near enough for me. Okay, so should we fire up the picoscope and see what's coming out of it? Okay, so one scope on the output of the microphone module, and just for interest I put the other scope probe on the output of the light sensor, just to see if there's anything funny happening at high frequency with that. So we'll turn it back round, because I sort of put the microphone on back to front. Can we see that? We can. We can. Okay, so here we are finally. And as you can see, the microphone is producing, just reproducing my voice quite nicely, so I think we're happy with that. And the light, yeah, it's seeing the outside and sort of overloads it, but we don't mind. So, okay, I think we're good for now. So we've got our microphone working, but what are we going to do with the input to that microphone? Well, I'd originally thought I was going to build a little circuit to amplify it if needed and rectify it, and then feed the rectified signal into the Arduino, because the Arduino just hasn't got the go to process audio. But then I thought, what if we want to do some filtering or something? Then we've got to add electronics or rebuild electronics, which gets to be a bit of a faff. I mean, I know you're doing a bit of soldering and a bit of fun, but I tend to think it's just so much easier doing that sort of thing in software. And as I said, the Arduino will not process real-time audio, it just hasn't got the go. So then I looked round at the cheaper Nucleos, because we're using a cheaper Nucleo in the mean green, which is an STM32 processor, and well, a genuine Arduino comes in at 20 to 30 pounds, and I know a copy's £5, but you can buy one of the more basic and when I say basic I don't mean very basic, Nucleos at £15 some and delivered this one, and this is of course it's ARM Cortex M3, 72 MHz, 120 kilobytes flash, 20 kilobytes SRAM, so that we can just feed our microphone signal in and do whatever audio processing we like. And for the cost, it seems crazy to use anything different. And I know the Arduino comes with lots of useful functions, and if you stay within what they do in the functions, their functions, it's very, very easy to use. But it's an old 8-bit processor, it just seems a bit 90s, a bit dated. And although it was easy to get these things going because we just put the colours in an array and called a function, you know, I sort of missed the challenge of trying to write some drivers and get them going ourselves. So the upshot of this ramble is that Arduino for this project is out and Nucleo is in. So the next time we work on this project, this is what we'll be using, and we'll get our LED strip working again, and we'll get our sort of sensors working, and hopefully we'll have the LEDs installed in the globe, and we can get on to doing some interesting stuff. So again, sorry for rambling a bit at the end of this one, but I will shut up now. So for now, subscribe please, comments welcome, thumbs up would be nice, and for now it's goodbye from Triplicate, home of interesting electronics. Goodbye.